Welcome back. Today we're going to be talking about the history of software-defined networking. We'll start by discussing the timeline of software-defined networking from the 1980s to present, and in doing so you should gain some awareness about where the ideas and principles of software-defined networking came from. And hopefully you'll recognize that some of the architectural themes that we see in packet switch computer networks today actually originated from quite some time ago and actually have their roots in the telephone network. There are 4 chapters in SDN history that we'll discuss throughout this module. The first is the evolution of supporting technologies. In particular, we'll talk about how programmable data planes, things like controlled data plane separation, took shape. We'll speak about the controlled data plane separation in detail, as well as its history, where it came from. We'll also talk about how different specific control channels for certain data planes, like communication of routing information between independently operated networks, evolved. And we'll talk about how after the proliferation of these different control channels and data planes, there's been some convergence. In particular, the emerging OpenFlow standard is an example of convergence of a control and data plane around a specific standard. Let's first start by talking about the evolution of supporting technologies. So we'll break this up into 3 different lessons. First, we'll talk about the origins of central network control, which dates back at least to the early 1980s in the form of AT&T's network control point, which is, by the way, still in use today. Next, we'll talk about the history of programmability in networks, which can be traced back to active networks in the 1990s. And then we'll talk about network virtualization, which some have described as the killer app for SDN, which also has its roots back in various technologies in the 1990s. So let's start by talking about the origins of central network control. So it wasn't always the case that networks had central network control. In particular, in the early days, control and data planes operated together in the same channel. This is a technology or a paradigm known as in-band signaling, where data and control, or in the case of the phone network, voice and control, were sent over the same channel. Certain frequencies in this channel, for example 2600 Hertz, could do things like reset phone trunk lines, and other types of things like pulses on the line could be used to route calls and set up circuits for calls. While this offered some advantages in terms of simplicity, the resulting network turned out to be fairly brittle, insecure, and so forth. In particular, here's an example or a picture of Steve Wozniak's Blue Box. Blue Box was something that various people, hobbyists, developed to send signals, pulses, frequencies over the phone network's channel to essentially take control of it. And this particular box was able to do things like reset a phone trunk line, route phone calls to a particular place, and so forth. In the early 1980s, AT&T took a particular turn towards separating the data and control planes in something called the network control point. So this was developed for the telephone network, and the idea was that in separating the control from, or the signaling from the voice and data, that this could enable a number of new services. In particular, it was used to develop the 800 service and several other phone services. So the idea was that all signaling would go to the network control point, or the NCP, which could also talk to a backend database, which could have additional auxiliary information about customers. So benefits of this particular technology were the ability to deploy specific services on demand, and also, more importantly, rapidly introduce new services, whereas in the past it might have taken quite a bit longer to deploy a new service. So in particular, the technical reports that describe the NCP talk about a number of different advantages. One is that elimination of in-band signaling reduced expenditures. Because they had a better view of what was going on inside the network, they were able to shorten the amount of time that particular circuits were held up. And more specifically, the ability to determine the busy or idle status of a circuit or a trunk line before requesting that circuit allowed for a more efficient and quicker allocation of resources. Secondly, the technical reports cite the potential for rapidly introducing new services. In particular, quoting from the article, it says, In the area of new services that can be supported, the possibilities are only limited by imagination. So the idea was that the NCP architecture would expose various basic primitives, such as collecting n digits from a number, sending and receiving messages, making a billing record, and so forth, and more complicated applications could be built on top of those primitives. One example of an envisioned service that the early reports describe is something called a person locator, where a user would register their specific location at any time with the NCP database, and the NCP would then route a call, which would be made to a more generic number. It would route that specifically to where the user happened to be at that particular time. So NCPs today are currently used to route 800 calls in a very similar fashion. So to summarize, the benefits of central control for something like the NCP and the phone network was that a single network-wide vantage point could allow operators to directly observe rather than infer network-wide behavior, and importantly, evolve the infrastructure, data, and services independently from one another. So that's a summary of some history of where central network control came from, and next we'll look at the history of programmability in networks as well as the history of network virtualization.